In Chapter 9 covers angles, and we're going to start with the very basic parts of angles today. Tomorrow we're going to talk about a new way to measure angles. It's called radians, so it's different than degrees. And of the 3 days, I think tomorrow is the most challenging, only because it's a new concept to wrap your head around. But today is probably the easiest of the 3 days on angles. So we're going to just do an introduction to angles, how we want to graph them, how we can label them, those types of things. There's going to be some similarities to geometry, but then there are lots of differences from angles in geometry to algebra too. Okay, so that's kind of what we want to concentrate on. First of all, in geometry, you could have angles just kind of anywhere in space, floating around in any orientation, no big deal. That changes in algebra too. We're going to want our angles to all be sort of located somewhere, and we're going to fix them to the coordinate plane. So we have something called standard position. I'll give you a minute to write this down. An angle in standard position is defined as an angle with a vertex at the origin. So throughout the chapter, all the angles you draw me will have vertices at the origin. Initial side on the positive x-axis. So I'll show you a picture of what an angle in standard position looks like. And this is how you'll draw them for me. Here's an angle in standard position. Notice you have an XY coordinate plane. You have a vertex at the origin. And then you have two sides to the angle. One side will always be the same, and that's the initial side. The initial side always runs along the positive x-axis. So this side right here will always be the same in all the angles that you and I draw. Okay, we'll always share an initial side. The angle opens from the initial side, and you can see this red arrow or this red arc telling me in what direction I'm opening. So my angle opens up through the first quadrant. It passes what is 90 degrees, and then it lands somewhere in the second quadrant. This other side is called the terminal side. So the word terminal here means to end, to terminate. Since that's a little bit over 90, but it hasn't crossed or gotten to the 180 degrees, the straight line, we could probably estimate that angle to be somewhere in between 90 and 180. Anybody want to give an estimate of degrees? They think that looks like a 135 degree angle. Okay, that would be acceptable. I think anywhere like 120 to 140, those types of things. I mean, just estimation, that would be okay. Okay. Now, the other thing that's really important is that red arc or arrow. So I'm going to be checking when you take your quiz on Friday that you draw that for me so I know what direction you opened. Because in algebra, we can have different angle measures depending on what direction we open. And that's our next slide. Okay. This is definitely different than geometry. In geometry, there would never be a negative angle. There weren't negative side lengths. It didn't make sense under the terms of geometry that we were working with. In algebra, we're okay with a negative angle because it just implies a different direction. So we'll have both positive and negative angles. Positive angles open counterclockwise. And negative angles open clockwise. So the red arrow, or the red arc that you draw in that very first picture, tells me what direction you went. So I know if you're graphing a positive angle or a negative angle. The angle that we saw on the previous slide, I just copied it right here. That's a positive angle. Okay. When we estimated it, we said like maybe 135. Okay. I had labeled the axis for you. We go up to 90 degrees and then around to 180. Okay, but we were going counterclockwise, so that was considered a positive angle. I could draw the same angle with the same initial and same terminal side, but it could have a different measure just by the direction that it goes. So this will be a negative angle. It's saying instead of opening up through the first and second quadrants, let's open down through the fourth, third, and then into the second. Each of the axes still marks 90 degrees, but when you label them in a negative angle, you label them negatively. So like in that very first example, I would have had a 0 degree, and then as I open counterclockwise, it's positive. 90, 180, and we estimated somewhere in between 90 and 180. Over here, we'll start at 0, but when we move clockwise, we have negative values. So this is negative 90. This is negative 180. And notice now my angle is going to be really greater than negative 180 or less than negative 180. Yes. Because I still haven't reached my angle. So if I add another 90 to 180, I think about my multiples of 9 here. 9, 18, it would be 27 or negative 270. Now when I estimate that angle, I'll estimate that angle to be somewhere in between negative 180 and negative 270. Anybody want to give us an estimate what they think it could be?
210.
Negative?
Yeah.
Okay. Negative 210. Okay. Any other estimates? Kyle? Negative 250. You know, I would lean maybe a little bit closer to 270, only because it seems like there's less space to go to 270. 210 would maybe be a little bit closer to 180. But again, that's just an estimation. Okay. So either one of those, as long as they're in between those numbers. Okay. Are we okay with that idea that we can go around negative? Okay. All right. The next thing we want to talk about then is an example where we're asked to draw them. So like, what do I expect for you to do when you draw angles? So our directions here are draw the angle in standard position. And then what quadrant does the terminal side lie in? Okay, so we'll answer that question. And I'll start with negative 120. I'll draw an XY coordinate plane, so this is what I would want to see like on your homework assignment. Remember that we always have the same initial side on the positive x-axis. So I'll go ahead and draw my initial side right here. And then I would start thinking about what direction am I moving and what's the degree. Okay, where would I put my terminal side? So I notice that this is a negative angle, so I'm going to be moving clockwise. And so you got to be thinking about the direction. And so I'll start at my initial side, and then that's at 0 degrees. And when I open clockwise, I'm at negative 90. That's still not enough. But I don't want to go all the way to negative 180, so we're going to draw our terminal side somewhere in quadrant 3. Very good. Okay, so we're going to draw our terminal side somewhere in quadrant 3. When I think about negative 120, it's a little bit closer to 90, so I might draw something like this. I've got my vertex at the origin. I have initial side on the positive x-axis. I've got my terminal side in quadrant 3 representing negative 120. The only other thing I need to add is that little arc that tells me what direction you open. And it's okay that yours are not color-coded like mine. Okay, so I color code mine, but that's all right that yours is all in the same color. Okay. Now, I have a second number up there, 400 degrees. What might be troubling to you about graphing an angle that is 400 degrees? Jackson?
The quadrants only go up to 360.
The quadrants only go up to 360. So we see this as a positive angle, this 400 degrees. It should go counterclockwise, so it'd start at 0. This would be 90, and then 180. And remember, I use my multiples of 9. 9, 18, 27, so this is 270, and I'm at 360. And we're right back to where we started. In algebra, we can wind around that coordinate plane as many times as we want. So once you make one full revolution, you've got 360 degrees. What if you add another 90 to that? Then you're at 450. So where does the 400 angle or 400 degree angle belong? Somewhere in between 360 and 450. So when I draw that angle, I'll have my initial side on the positive x-axis. I'll have my terminal side somewhere in between 360 and 450. And this is the really fun part. When you draw your arc, you draw a spiral. Because if you go more than once, and you can go, I could have you go around 5 times. And you'd have to draw 5 spirals. Okay? But if you make a full revolution, you need to show that in that arrow or that arc that you draw for me. So I would start at my initial side, and remember this is going counterclockwise. So I'd start, and I would start my spiral, and I'd say I have to go around one whole time, and when I get to that initial side, I have to keep going. And I have this awesome spiral drawn that shows me that's more than 360 degrees. That's not just a 40 degree angle, that's a 400 degree angle. And you can have spirals go clockwise too. If I asked you to graph, let's say, an 800 degree angle, then 800 degrees, you have to go around once to get to 360. You'd have to go around twice to get to 720, and then you'd still have to go 80 degrees. So you would have like 2 parts to your spiral, and then a little extra. Are you guys okay with this? I think that drawing the angles in that way is kind of actually fun, because you get to draw the spirals. It's pretty awesome. The last thing to discuss before we do our activity is what a coterminal angle is. And this, I think, is probably the most brand new piece of information, and it will take us a little bit of time to learn this. So coterminal angles, go ahead and write this down. And then we'll look at an example, and then you'll get some time to practice all of this new information with angles. Okay, coterminal angles. Think about the word coterminal. We know terminal from the ending side, and co usually means together. So this means that we have angles that have the same terminal side, the same ending side. If you already share the initial side, and then you also share the terminal side, you really are the same angle. Okay. But the big difference here is you're the same angle, but you have different measures. Okay. It could be the difference between like a positive angle and a negative angle, like we saw on our positive negative angle definition. Or it could be the difference of one revolution, like we just saw. Okay. The angle that we drew was really a 40-degree angle in the first quadrant, but it had an extra revolution, so we called it 400. Okay, because we went around 360. So it's the same angle, but it is different measures. And to find coterminal angles, you add and subtract 360 degrees. Okay, and you'll do this like as many times as you want to get as many coterminal angles as you want. Most of your examples that you do and the problems in your homework are going to ask you something similar to this. They're going to say, find one positive and one negative angle that are coterminal with the angle I give you. So we'll start with negative 100. So we want to find two coterminal angles to negative 100. One that's positive and one that's negative. And once we've done that, then we've answered the question. If I were going to work this example with negative 100, I would start with negative 100. Since it's already negative, I can think in my head, to make it the opposite, to make it positive, I'm going to have to add 360, right? So I'll just add 360. And I come up with 260 degrees. That's a positive coterminal angle to negative 100. To find a negative coterminal angle with negative 100, I know that adding 360 gets me into the positives, so instead of adding 360, I'm going to subtract 360. And I'm at negative 460. Those three angles are the same angle. I'm going to draw them, I'm going to sketch them real quick, and just show it so you can see visually how they're the same, but what's different about them. Okay. So for negative 100, and you don't normally have to draw out all your coterminal angles. For negative 100, I would start with initial side on the positive x. Since it's negative, I'll go clockwise. And one quadrant is negative 90, but I have to go a little bit more than that, so I'm somewhere in quadrant 3. something very close to that y-axis. And that's my negative 100 degree angle. If I were to graph the 260 degree angle, I would start with my initial side on the positive x-axis. Since it's positive, I would go counterclockwise, and I would count my quadrants. The first quadrant is 90, the second quadrant 180, the third quadrant 270. I don't want to go that far. I'll back it up 10 degrees, and again, I'm somewhere in the third quadrant. Notice that the angle is the same. The only difference there is what direction I'm moving to get to my angle. So they're actually different measures. And the last one, if I draw that negative 460 degree angle, I can use my angle measures, and I'm going clockwise here. I'd be at negative 90, negative 180, negative 270, and I'm back to negative 360. And then if I add another 90, this is now negative 450. I want to go 10 more than that. So again, I'm going to land in the third quadrant. When I draw my angle, I'm going clockwise. I have to make one full rotation and then an extra 100 degrees to get to that. So they're really all the same angle, but their spirals are different because they have different measures. Let's say I give you 575 degrees and I ask for one positive and one negative coterminal angle. What might be troubling to you about the number 575 at first? Faith? Yeah, if you take away 360 one time, what kind of answer will you be left with? 215, which is positive. So I would notice, or I kind of keep my eyes peeled for problems like this. If the number is bigger than a rotation, I'm going to subtract it once to get 215. And that's my one positive coterminal angle. And then, Faith, you said, subtract it again. Take now 215 and subtract 360, and you'll have negative 145 degrees. So this is really like you subtracted 720. You subtracted 2 rotations. You had to back up an extra time in order to break into those negatives. So now I have one positive and one negative. The only reason I like to show you that is I like to do less work, as least amount of work as possible. You guys know this already. And so if I can kind of keep my eyes peeled for numbers that are larger than 360 or less than negative 360, I can really like add twice or subtract twice, maybe 3 times, but that will take care of my positive and my negatives, and I won't have to like do 575 plus 360 and then 575 minus minus. So I'm just kind of shortening my work. If you gave me the 575 plus 360 number, that's totally fine. That's not a problem at all. Okay. Does anybody have any questions about any of the topics that we've covered?